Hello everybody, Chris here, and in this video I want to give you guys a quick start into the Unity game development engine. So some of the topics I want to cover really quickly in this video, just to give you guys a rough overview of what can be done within Unity, include explaining game objects and scenes, game objects being objects that exist inside of the scenes and have components attached to them to give those game objects functionality. So we'll be talking about components such as sprite renderers, which allow you to render an image for a game object or a canvas UI element. Tile mapping, in order to draw your game levels with 2D tiles. The very basics of how to set up an animation controller with animations. A tiny bit about C# scripting in creating a player movement script. And we'll also be talking a little bit about the game world versus the canvas UI, which layers on top of everything. So when you create your first Unity scene, you're going to see in the hierarchy the scene name itself. And under that is going to be the main camera game object. You know you're looking at a game object because next to it is going to be this little cube shape. And you can left click onto a game object in order to see details about it showing up in the inspector, which by default is on the right hand side. So under the main camera game object, you have different components which contain either default Unity functionality or custom scripts which you've created, and you attach multiple of these components generally to a single game object in order to give it all of the things that it can do. So what every game object is going to have is a transform component, or in the case of a UI element, it'll have a rect transform component. For normal game objects in the transform component, it will have position, rotation, and a scale. So before you add other components to a game object, it has nothing really attached to it except for the position in 3D space and whatever rotation or scale that a game object should have. But without extra components like a sprite renderer, these aren't really going to do anything. You can see that the main camera game object has a camera component to it, which obviously allows it to view a certain area of the game world and render that to the screen. And you'll notice I'm on the game tab in this preview area. And what it's previewing right now is the output of the main camera. So you can see that by default this has a blue background, which of course is something you could change to a different color by clicking on the color selector quite easily. But if we go into scene view, it's going to look a little different, and probably what you saw at the start was the scene view. So I can double click on the main camera, and what you'll be able to see here is the gizmos indicators, showing basically the bounds of the camera view area. But there's nothing else inside of the game scene. Now generally, a game is going to consist of multiple scenes, so you might have a scene for the main menu, you might have a scene for each level, or just one main scene which you would load the quote-unquote levels on top of. But at a base level, what the scene is just a default collection of game objects which are going to be loaded into it by default. So inside of my assets folder in the bottom project area, you'll see that there's a package here called Sunnyland. So I picked this up from the asset store. It's freely available. And on the asset store, you can actually find a lot of things such as 2D sprite packs, which may contain animations for a character, scripts for adding functionality to your game without you having to code everything yourself, or 3D models if you decide to go with a 3D game. So just note that you can use the Unity Asset Store if you want to reduce some of the amount of time you have to put into the game by coding everything from scratch. And by the way, for windows like this, in Game and Scene, in the Inspector, if you don't ever see any of these, you can open them up in the Window menu. So the Asset Store could be Window and then Asset Store, and then other tabbed windows can be opened up in categories such as General over here. So once you have some art assets for your game, and you may create that in Photoshop, AssetSprite, or for 3D models, something like Blender, then you can load those into your game as asset files. So if you wanted to get started by creating a new game object for a player, you could go into the artwork for your game, find the sprites, and generally you'd want to start with the idle sprite. So I'll just drill in here, and you'd have player 1 idle. You can bring that into your game scene as a brand new game object, and you'll see that with this game object, it immediately attaches a sprite renderer there, and it will have that image you dragged into the hierarchy attached. We can double click on that, and you can see that it is actually really tiny right now inside of the game. If we go to the game view, you can see that the sprite is rendering really tiny, and that's probably going to be too small for the game. So one way of adjusting this would be to increase the scale of your game objects, but you might have to do this for every game object if you are bringing in these small sprites. You can also click on each of the images that you're bringing in for your project and change the pixels per unit from 100 to something smaller like 16 or 32. But if you do that, generally you're going to want to be consistent, so you want to apply that to all images in your game. And you can do a multiple selection of all of your images and then change the value all at once, so you don't have to do it individually. But another option, if you only want to change things once, could be to go to the main camera and to decrease the camera size. So if I drop this from 5 to 1, you'll see that the camera view space is now a lot smaller, but it's still going to be putting that out to whatever screen size you have. So in a sense, your game objects will look a lot bigger because the camera is showing less at once. So with this game object, I could recreate everything from scratch here, adding components to it. But I have a bit of a prefab already created. So a prefab is a game object which is saved to your assets folder and will contain defaults for a certain type of player, enemy, or other game object within your game. So with prefabs, you can actually drag them into any scene, and you could create multiple duplicates if you wanted as well. But you can drag these into your scene and copy basically the defaults for this prefab straight into your scene. So you can see here that this prefab has a sprite renderer, it has a capsule collider, a rigid body, and a player controller script, and we'll get into those more in a minute. So that can be a bit of a time saver if you ever want to reuse any of your game object assets. And once you've created something as a prefab, but you want to be able to go into an editor where you can change the defaults for the prefab, you'll be able to see that the game object in the hierarchy now has a blue cube instead of a white cube, indicating that this is a prefab, and there'll be an arrow over here on the right. So we can click on that arrow, and this brings us into a prefab editor. So now whenever we make changes to this prefab in this mode, those changes will be applied across the board to any instance of the prefab or a copy that's inheriting values from the prefab. Now you can assign overrides, which means that the copy will have a different value than the prefab even if you change it over here. But you can completely define which properties for which copies should inherit from the prefab or have their own values. So while I'm in here editing the prefab, you may have noticed that the capsule collider, and we should go over to scene view in order to better see our prefab. If I click on the game object over here, you can see this green capsule collider going around the character over here. And you can see that the bounds of this collider don't really match the sprite. So I can hit Edit Collider and adjust the shape of the capsule collider using these gizmos tools, basically clicking on one end and bringing it down. And then that'll give us a better shape for the capsule collider to match the sprite of the character. And now if we click on the back arrow in the hierarchy and we go back out to our scene, you can see that the capsule collider in our scene is updated to the same values that it has in the prefab. But we can customize any values we want to as an override by just typing in a number. So I could have position of 5 set for the position for this player, but we go into the prefab and you see that it's set as 0 over here. So now this player in the scene has a override. And if you want to apply all of your custom values into the prefab, I guess transform isn't included, then you can click on this overrides menu, which will show you all of the changes, and there'd be a little apply option. So if I change the sorting layer, just a random property, I could apply all of these overrides to the prefab to copy those same settings to all other instances of the prefab. But I'm going to take the sorting layer and put that back to 0 for now. And we'll also take the position and put that back at 0. And one of the next things you're probably going to want to know after adding a player into the scene is how do you add a background. So the camera is going to render game objects to the screen for the player. So what we could do in a 2D game is put a background image behind this player, and then the camera would show that to the player as well. So in order to add a background image, we can right-click on our scene hierarchy, and we could go down to 2D object and then sprite to create another game object. You could also drag a background image straight into the hierarchy for pretty much the same effect. And I'll call this background. For sprite, I'll click on this selector here and I'll find the background image inside of the project. So I'll just click on that there. And so now we have a background image that's rendering as a 2D plane in 3D space. So what I mean is when you have a 2D project, you can click off 2D view and you can actually see that every object inside of the game is still a 3D object, even though you're creating a 2D game. So everything still exists in 3D space, technically speaking. But as long as your camera is looking directly at these 2D planes and sprites, there would generally be no functional difference than if you were using a purely 2D engine. So one thing that you'll often run into if you're creating a game in 2D like this is that you'll need to render the right objects in front. And a great way to do that is by using the sorting layer settings in order to determine which order things should be rendering. So the background should be in the back, and then anything else should render on top of that. So if I click on sorting layer here, there'll be no other layers by default, but I've already gone ahead and created one. So if I click on add sorting layer, it'll pull us over to this tag and layers menu. And you can see that in sorting layers, you have plus and minus buttons to add and remove layers. And the layer that is on top here is actually the one that's going to be the most background of the layers. And the ones that are at the bottom are going to render on top of everything else. So we would want our player or default layer to be below the background layer in this case. Now what we need to do for any object that should be a background layer sprite, we just change the sorting layer to background, and then that'll allow anything that's like a player or a tile map to render on top of that. Okay, cool. So there's a couple more components inside of the player prefab. You can see here a rigid body 2D. Now it's set to dynamic by default, which allows the Unity physics engine to interact with this character, which is really cool. You don't have to program your own physics engine or anything. You can see in constraints, I've set freeze rotation Z. And the reason I've done this is that we always want the character to be upright in this case. Generally the case with more classic kind of pixel art games, you wouldn't really want them to rotate on their side. Though if you do want that, you can just kind of not have freeze rotation checked here, and it will be able to rotate around. So note that there is a gravity scale here, so the physics engine will automatically apply gravity to your game objects that are set to dynamic mode. So if I go to the game view and I hit play, the character is just going to fall off the screen in about 1 second. So in order to not have your character immediately fall off the screen, you'll have to have some kind of ground for it to stand on. So a really great way of creating ground, or the base level for a scene to take place in, is to use tile mapping in order to take one tile and repeat it a bunch of times in order to create easy ground, and you can kind of customize the shape by using different tiles. So in order to add in tile mapping to Unity, you need to go up to the window package manager, and you're going to need to type in and find these two packages if they're not installed already. So 2D Sprite and 2D Tile Map Editor. You'll need both of these, so you can just search up here in the toolbar, type these in and install them. These are official Unity packages. They're just not included in every project by default. It wouldn't really make sense if you took every package and loaded it into every game you make, because obviously not every game is going to need every functionality. But this can also be a cool way to find other tools to check out, such as Cinemachine, which is a really handy camera tool. But once you have those installed, you should be able to go up to Window and 2D and open up a tile palette window. So over here next to Inspector, you can see that I have the tile palette window. And in here, we can create a tile palette, which we attach images to in order to create tiles. And the tile palette is basically the manager for all of those tiles that we can draw onto a tile grid inside of our scene in order to create the level and store that within the scene. What I'll do is over in the assets folder, I'm going to right click and create a new folder, and I will call this palettes. And this will be where I store my tile palettes. So I'm going to create a new palette here, and I'm just going to call it tutorial 1. Leave it as rectangle and automatic in this case. Note that you can also do hexagon and isometric tiles if you're more into that, but rectangle is probably standard for this kind of perspective. So let's go ahead and hit create here. And I'm going to store this tile palette file in the palettes folder. And you can see that it's been stored in there now. So in order for the tile palette to actually be useful, we need to attach some images to it. So inside of the environment folder, there's a tile set image and a tile set pre-sliced image. Now, generally, if you grab a tile set from somewhere online, it's not going to be pre-sliced. You'll have to do it yourself. So I'm going to click on the tile set that's currently unsliced and go into the sprite editor. But first, I'm going to change sprite mode from single to multiple. You do have to have the 2D sprite package from the package manager in order to change it to this mode. So let's go into the sprite editor. I'll hit apply to apply that multiple mode setting. And from here, we want to slice up the image based on the number of pixels per tile. So I know that the number for all of these tiles is 16. You can see I've kind of pre-done it. But if you want to reslice it, you go up to the slice button up here at the top, change it from automatic to grid by cell size, and change it to the pixel size for each of your tiles. So I'm going to slice it here. And so these single tiles, such as the ground, are now their own individual selection. Some of the objects in this tile set actually take up multiple tiles. So you can see here for this little log that comes out of a tree that to actually place that in your scene, you would need to place 3 tile spaces. So this should be fine as long as your tile set was designed with a specific unit in mind, such as 16 pixels by 16 pixels or 32 pixels by 32 pixels. So let's click on the X here and apply to change this into the multiple slice mode and go over to the tile palette. So in order to properly bring in a tile set to a tile palette, what you should do is instead of dragging individual images, such as holding shift down like this, and selecting all of the images individually, you drag the image itself, the original image, into your tile map editor. And then this will keep the positioning of all of the tiles that you had in the tile set image. So if I drag this in here and we go to the palettes folder, we need to store tiles in here. So I'm going to say tutorial 1, and I could add tiles to that, but I think it's kind of self-explanatory. And I'll hit select. We generate the 128 tiles into that. But you can see that the positioning of all of the tiles is exactly like it is in the image, and that will make your life a lot easier. So now we can draw onto a tile grid with any of these tiles and basically create whatever kind of game level we want, which is super cool. So in order to start doing that, we need a tile grid game object. So I'm going to right click in my scene, go down to 2D object, I believe. And when you add a tile map game object, the grid is created immediately. Under that, a tile map child game object. So you can see the hierarchy. Parents are at the top, children are at the bottom. Same thing when you get into C# scripting. And you can see that on these game objects, there are different components attached. The grid has only a grid component, and the tile map has a tile map and a tile map renderer. For the tile map renderer, it might be a good idea to create a sorting layer for it. So I can add in a sorting layer here. We'll hit plus. I'll call this tile map. And we'll put this between the background image and the default player / enemy layer. So now we can take the tile map and change its sorting layer to tile map. So that'll just keep the rendering more organized as things get more complex. Now you'll notice that the tile grid is really, really big in its tile sizing. So what we want to do is go over to the grid, and because we haven't changed the pixels per unit of any image within our game, that means that it's defaulting to 100 pixels per unit, but we know from cutting up the tile map that each of the tiles has 16 pixels in its data. So we need to shrink the cell size of the grid accordingly. So 100 pixels down to 16 pixels is going to be 0.16 for X and Y. And just like that, our grid is now set up properly, and the tiles that we try to draw onto the screen are going to be in the right position and the right sizing. So now we just go into the tile palette and we can start drawing on the grid. So I take this tile, I click on the grid, and we add that into our game. We can add a whole bunch of the middle top ground, and we can add one for the right edge. We can go down here. Note the organization by dragging in the tile map properly allows us to keep things organized. And we can just keep drawing this little island for a platformer type game and fill in the middle section with a bunch of black spaces. Now when you have a lot of spaces, you don't have to draw them all individually. You can use the paint bucket tool and you can just fill in an empty region with the same tile, just like that. So now we have a ground, but the thing is, it's not actually going to stop the player from falling to their death yet, because there's no collider on the tile map. So if I hit play here, you'll see that it'll fall straight through the ground. So in order to change that, and you may not want a tile map collider on every tile, because some tiles you actually want to be able to fall through, such as water in a Mario game, but we can add the collision to a tile map by clicking on Add Component here and Tile Map Collider 2D. So if you want some tiles to be collidable and some to not be, just create 2 tile maps on the grid, and that should be a really easy solution. So now with this tile map collider, and in the player, the rigid body and the capsule collider attached, as long as this is a 2D, then these should be able to interact with each other properly in the physics engines. So when the player falls down, he stops right at the top of the ground, which is what we want. Now this player already has a really simple player controller script attached to it that allows it to move left and right. So you can see here, hit left and right on the keyboard, and it accelerates as time goes on as long as I hold those two keys down. So if I go off the tile map, they can still, of course, fall down indefinitely. So let's open up the player controller script and take a look at it. It's not really too complicated here. So you can see that the player controller script inherits from mono behavior. So as long as you're working with game objects instead of the entity system, which I don't think is 100% out yet anyway, then any component you attach to a game object is going to be a mono behavior script. So whenever you create a script, it's going to have this by default, and then you can take these scripts and attach them to a game object, such as your player. After that, you can see I've declared a couple of variables. Note that any public variable is actually editable inside of the inspector for a Unity game object. So if we go back over to Unity, you can see here for this player script that I've attached to the player that the move speed is editable. So although I might declare a certain move speed in the script, I can override that by changing the value in the inspector for a player. So it's really handy. You don't always have to go back into the script if you just want to change some of the values, as long as you make those variables public. We also have reference to a rigid body, and this rigid body 2D is a component. So whenever you want to get a component inside of Unity 2D, you call get component rigid body 2D, or whatever the type of the component you're trying to get is. And then this will look at the game object and see if the component is attached and return a reference to that. So I store that reference in this rigid body 2D variable. And with that, I'm able to reference the rigid body 2D variable and other methods or functions that are attached to a class for a Unity 2D script. So in order to get the input from the keyboard or whichever controller happens to be attached to the game, we can do input.getAxisRaw. Then we get the horizontal input from the controller. In this case, it's the keyboard, so you'd be looking at left-right arrows. And we assign that to a float variable. A float is just a number that supports decimal points. If the input value is not 0, indicating we're getting some kind of input. And if we are, then we move on to creating a move vector. So vectors are going to be super important in game physics. They have a magnitude and a direction. So the idea is that whatever the x and y values of the vector are going to be is how much you want it to move in either x horizontal movement or y vertical movement in this case. So a vector isn't always going to be a movement value, but it's always going to be a direction and a magnitude or the value. So the idea here is that if the input is negative, as in I press left on the keyboard, then the input's going to be negative. And if I press right on the keyboard, the input's going to be positive. We multiply that by a move speed value, how fast we want it to start accelerating. We could actually rename this variable to something like acceleration, and that might make more sense. So why don't we do that? In Visual Studio, we can rename both of these at the same time by right-clicking and doing rename. So I will call this acceleration and hit apply. And we take those values and we multiply it by time.delta time. So what delta time is the time since the last frame update. In a fixed update method, theoretically, every frame should be an exact amount of time since the last one has occurred, but in a void update method, the time.delta time won't be consistent. So by multiplying our values by time.delta time, whenever it updates, we modify the amount of force that it's applying to the object based on how much time since the last frame. So this will help the movement look a lot more consistent regardless of how often the update method is running. And by the way, for mono behavior, these will automatically run by default. A wake will happen whenever a game object is added to the scene initially, whether it's enabled or disabled. If you're curious, you could look into Unity mono behavior life cycles, but not really too relevant for right now. So anyway, we take our movement vector and then we add it to the rigid body. We add it to the rigid body because the rigid body works with the Unity physics engine in order to determine how a character should move. So for instance, if you try to move up against a wall, even if you add the force to the rigid body, it's still not going to move because there's a wall there. Now, if you wanted to have jumping or that kind of thing, then your vector would need a value for the y parameter over here. So y is vertical, and this one on the left is x value for horizontal. But in this case, we're only trying to add force to the object to make it move horizontally. So in a nutshell, that's how our character is able to move here. I'm going to change the acceleration value back to 300 here because it seems like it needs to be higher for the character to move at all with the physics engine there. So at 300, we get a reasonable move speed, as you can see here. Okay, so next let's talk a little bit about Canvas UI elements. When you want something to draw on top of the screen, but be independent from the game itself, as in a button that isn't really something your characters would collide with or care about in any way, then you put that on the top layer called the canvas. So the canvas will contain buttons, text elements for displaying text such as your character's HP or that kind of thing. And we can add a canvas to our scene by right-clicking and going down to UI and Canvas. So with this canvas game object, it will render everything nested under it, all of the child game objects, to the camera, regardless of where the camera is looking at. So the canvas is kind of separate from the main game world, and it's an overlay that will sit on top of your game. In the prefabs folder, I've created something called a launch button. So I'm going to drag this prefab onto the canvas. This is basically just a button canvas element. If you want to create something like a button by default, you can right-click on the canvas, do UI, and add in a button, a image if you want like background for your main menu, text elements, sliders, scroll bars, all those kind of things. Basically works the same way that similar elements would be on a website. So we can see that in the scene, the canvas has the button over here in the bottom right-hand corner. So the way it's determining that is with the rect transform. So the rect transform is going to allow you to set anchor points to the canvas. You could kind of think of the canvas as the screen itself, because the canvas's size and position is going to basically perfectly match the screen itself. So if I go into game view and I change the resolution here to standalone, you can see that the canvas adjusts the position of all of the canvas UI elements based on the screen size. But if we go back to scene view, you can see that the canvas's shape and size is dependent on what resolution you have set for the game. So if we want to take this button and move it to the top left-hand corner, I can click on the Anchor Presets button over here, and I'm going to do Control-Alt-Shift to set the pivot, the position, and the anchor point to the top left-hand corner, which puts it squarely up there in the top left-hand corner, regardless of what size the screen is. So if I change it back to 16:9 ratio, then it's still going to be up there in the top left. And we can adjust its offset position by adding in a X value and a Y value. And I think we want -40 here in order to move it down for the Y value. So it's not too hard to position canvas UI elements. And if you want your UI elements to scale with the size of your screens, so they will appear much bigger on a big monitor with a high resolution, then you can take your canvas UI element in the canvas scaler, and you can change the scale mode from constant pixel size, which will mean it's always the same size regardless of the resolution, to scale with screen size. And you would want to have a reference resolution set, so you know the default size for everything on the screen based on that reference resolution. So I could do 1920 by 1080, which is a pretty common resolution. And then I just need to take each of my canvas UI elements and change their size so that it fits the reference resolution. So for instance, I can go into the text game object and increase the font size from something like 14 to 46. You can change your font here too, by the way. And now you can see that the text is not fitting the button, so we need to increase the size of the button itself. So I'll do that by increasing the width and height of the button. So something like 400 by 60 or 400 by 80 should be pretty good. And with those settings, you should get a pretty consistently positioned and sized UI element. So now you might be wondering what the launch player button does. So you can see under the button script, which is attached to every button UI element by default, it has a on-click event. And this on-click event, you can add functions to it, which basically reference a script and then reference what method you want to call from that script and executes it when the button is clicked. So the script I'm referencing is the player mover script, which I've attached to this button as well. And we can open that up by clicking on the settings icon over here and then doing edit script. So this player mover script, it has a launch vector, which is basically whatever settings you want to add to it, the magnitude and the direction of this launch, so to speak. And then when the launch all players method is called, it's going to find all objects of player type, player controller, basically all game objects that have a player controller component, and it's going to get reference to the player controller component within those game objects within the scene. This isn't necessarily the best practice way of referencing the other game objects within your scene, but it will work for simple stuff like this. So we have a list of all the player controllers, and for each of those player controller scripts, we want to find a rigid body 2D component and add the force to it, this launch vector up here, in pretty much the same way that we had for player controller. But you can see that this had time.delta time as part of the calculations for this input. But rather, when we do it this time, this is more of a one-time force, so we don't bother with time delta time at all. but rather we just add the force all at once. So if we hit play on our scene, we can actually use this button to launch the players in our game. So I'm going to hit launch player, and you can see it makes it hop. If we had other game objects in the scene that had a player controller component and a rigid body 2D component, then we could be able to launch all of them simultaneously with this button. So that's a pretty cool way of having things interact with each other. And now note one thing, when I was making this player controller script, if I open that up, I had require component type of rigid body 2D added up here at the top. So what this will do is that whenever you add a player controller script to any game object, and I'll show you just by opening up this background randomly, and we add in a player controller, that it will automatically add a rigid body 2D along with it, because this script depends on having a rigid body 2D, and you can see we can't even remove it until we remove the player controller. So that is one way you can tell Unity about that, so that you don't accidentally forget components that are required for something like a player to work. Okay, so one more thing that we can touch on is the basics of doing animation. So in the Sunnyland package, we have all of these wonderful sprites like climb animation, crouching animation, jumping, running, and that kind of thing. So in order to have your character animated, it needs to have an animator component attached to it, and that animator component is going to have an animator controller, and the animator controller will be responsible for going between different animations depending on whatever state your character is in, like if it's actually moving or it's just idling in place. So if we go to the player game object, and let's actually do it at the prefab level. So I'll open the prefab asset, so that this applies to all players. I can add a component for the animator by typing in animator for the add component. And this is going to take a new runtime animator controller. So I could create a folder in our assets to contain those animator controllers. I might call this characters or something like that, and organize all related character assets into subdirectories. But I'm going to need an animator controller for the player. So I'm going to right click, do create, and then do animator controller. So I'll just call this player underscore animator controller, or animator controller underscore player, whatever you want. So we need to attach this animator controller to the animator component. And inside of this animator controller, we link together the animations in order to have the images change out properly as the character's moving around doing things. So let's start by adding in the idling animation. If we go up to Window and Animation, you can open up Animation here, or alternatively Control-6 on your keyboard. So although we have an animator controller, we have no animation clips, so we can click on this Create button to make our first. I'm going to store this .animation file in the characters folder, so we will call this idle.anim for animation. And now we need to add into this animation timeline the frames that the character should be playing through while the character is idling. So inside of the Sunnyland package, artwork, sprites, player, and idle, we have 4 frames. So we're going to need to cycle between these frames in some way. The easiest way to add them to the timeline is just to select them all. So I'm going to left click on the first one, hold shift, and then left click on the final one, and drag these into the timeline. And you can see that there's now 4 frames that have been created for these different images. You can expand it to see those little sprite frames in the timeline. And now we basically have a simple animation. So if I go over to the scene view to see the prefab object over here, and then we go to frame 1 and hit play, we should be able to see the character animating. Now, right now, it's really, really fast, and we need to slow that animation way down. So the dope sheet is animating with 60 frames by default for every second. So if I have the sprite change every 10 frames or so, that should make the character's animation a lot slower here. So I'll just spread these out, one at 30, one at 20, and one at 10. And if I hit play here, you can see the idle animation has slowed down dramatically, and that's probably more like how it was supposed to look. So we can stop that animation there. If we open up the animator window, which you could do by going to Window, Animation, and Animator, you can see the animation flow for the animator controller, which is attached to the character. So the entry point is going into idle, but we probably want another motion in the character's animation, such as one for running. So to create a new animation, we can click on the drop down and do Create New Clip in the animation window, and we will do run.anim. So for this animation, we need to do basically the same thing, grabbing the frames for the run, and I'll grab all 6 of these, put them into this animation clip, and spread them out as we think they should be. So because the running probably needs to look a little faster, I'm going to make it every 5 frames instead of every 10 frames. So let's get that moved over there. And we're also going to want to copy the first frame over to somewhere around frame 29 so that the animation gives the last sprite frame a few runtime frames to actually be there. So if we hit play, this should start to look right. And we probably want to also do that same thing for the idle animation. So for the idle, I'm going to go to frame 39 here and copy and paste that in for the first frame, so that when it gets to frame 40, it's just going to loop back to frame 0. And if we hit play here, we can see the character animating correctly, as well with the run animation. So now we just need to tell Unity how to go between idle and run. And we can do that by setting a parameter in the animator controller. So you can see that there is an empty list of parameters here. So we want to add in this case, it's going to be a float, and we'll call it input x. And so this input x value is going to determine whether it is in a idling state or a run state. So in order to go from idle to run, we need to right click and make a transition to run in order to set a path where it can change from one animation state to another. And for the condition along the arrow for this transition, we want to set a condition, which is that input x is greater than something like 0.1. We can test this and make sure that it's working nicely. And for run to idle, I'll make a transition. So it will return from run to idle if the condition of input x is less than, and we'll say 0.1. We'll also turn off exit time for both of these transitions so that if the condition is met, it will immediately change to the other animation. And turning that off for the idle to run as well. And now we just need to have a script tell the animator controller what the value of input x is. So the best way to do that, is going to be to go over to player, find the player controller, and we'll do edit script here. And we're going to need to reference the animator component so that we can set the parameters on that component. So I'm going to need a private animator here, and I'll just call this animator. And just like with the rigid body, we'll do animator equals get component animator, which will find the animator component on the game object if it exists. And what we'll do is check if there is an animator, then we will set the value of that parameter. So animator.setFloat, to set a float parameter, is going to be the name of that parameter. So input x, and then the value is input x. And then the value is input x without the quotations. And then that should be all we need to do in order to have the player controller update the animator. So let's make sure that the names are consistent, the parameter there, same name in code as it is in the animator window. So let's go back to the game and find our player here, go to game mode and hit play. So you can see that the idle animation is there by default, and it's staying there because there is no input x. But as soon as I start pressing left and right on the keyboard, that actually causes the character to animate. Right now it's only in the right direction because negative input x is actually still less than 0.1, technically speaking. So what we can do to fix that is to use a math function to make it an absolute value. So I'll do mathf.abs for absolute value to take the absolute value, which means you remove the positive negative sign and you just take the magnitude of the value. And that's what we'll actually set as the input x float. So now the character should be able to move left and right. However, the character is always still facing to the right. So one more thing we can do is if the value of input x is negative, we can tell the sprite renderer to flip x. So that'll make the character face left. So we'll only bother to add this functionality if the input's actually changing. So we'll only add this functionality for the condition that the input actually exists. Otherwise, there would really be no need. So I'll just add below here after the rigid body add force to set the sprite renderer to flip based on whatever direction the input x is. So this will be another component that we need to add in up here at the top. So sprite renderer, and I'll call it sRenderer so that there's no name confliction. and we will get the sprite renderer component so that we can set the flip value. So the flip x value is a Boolean, so we basically want to say whether this is positive or not. So we can type this logic in but like this: input x is greater than 0, and we evaluate that to either true or false. So if it is true, then it's going to flip x, and if not, then it is going to set the flip x to not be flipped. So we actually want to reverse this. So I'm going to do false and true, because if the input is greater than 0, we want it to be facing to the right, which means we don't want it to flip. But if the input x is less than 0, we want it to evaluate to true, so that it will flip and face the left. So now we can go back into the game, hit play one more time, and the character should be able to run left and right depending on which direction we are pressing on our keyboard. So you can see the sprite renderer is updating there in real time, and that is super, super cool. So already we have a lot of the basics set up for how we could create something like a simple 2D platformer. You would just need to add in game over victory logic, how it interacts with other things such as collecting coins, maybe add in a function for how to jump, how enemies should move around the stage and interact with the player, and all that other kind of thing. But hopefully this video has given you guys a good quick start into Unity game development. So I've been Chris, thanks for watching, and I'll see you guys in my future video content.